Section 4.8, Trigonometric Applications and Models. For our first example, we're going to find distance just using a right triangle example, and in this case we're actually going to find two distances, then find the difference between them. So we have an observer in a lighthouse 350 feet above sea level, observes two ships directly offshore. So we've got some person standing up here, 350 feet above sea level. We're looking at the angle of depression to the two ships are 6.5 degrees and 4 degrees. So how far apart are the ships? So when you're looking at a question like this, you first need to think about the picture. Do I care about the distance of the hypotenuse? Or do I care about the distance D? And since we're trying to find the distance between two ships, I'm really looking for this distance here between the two ships. So I know that I'm going to be finding these two lengths. So that's half the battle, is knowing that. Now, we know we have the triangles drawn this way. Keep in mind that if you have a triangle drawn this way, where this is 6.5 degrees, then you can also draw that angle here or here. So it doesn't matter if you are looking at this triangle and this triangle or the opposites, they're going to give us the same thing. So let's start with ship 1. So ship 1 is the closer, that has a degree of 6.5 degrees angle of depression. I'm looking to find little d. So to find little d, I'm looking at 6.5 degrees opens up to 350, and I'm trying to find that opposite side. So this is a tangent function where the side opposite 6.5 is 350, and the side adjacent is what I'm trying to find. So I used A for that, not D. And I found that that distance is 3071.9-ish. Now I'm going to do the same thing for ship 2. Keep in mind, again, ship 2, the degree is 4. But you can also think about this degree of 4, if that helps you get it visualized in your mind a little bit easier. I'm trying to find what is labeled on this picture as big D. And again, the side opposite the 4 degrees is 350. And then I'm looking for the adjacent. So again, I'm going to use tangent. So tangent of 4 degrees, I find that distance to be 5,005.23 feet. And then I'm just finding the difference between that. So the difference between the ships is approximately 1,933 feet. Let's take a look at an air navigation question involving bearings. I do want to point out that the way that they measure air navigation is different than ship navigation, so we're going to do one of each to make sure you're comfortable with both. So to begin, we've already given you a picture here, but I want to stress to you that you won't always get a picture, and so make sure that you are able to come up with this picture on your own. So we have a jet flying between Reno, Nevada and Miami, Florida at a bearing of 100 degrees. So I have Reno and I have Miami, and the bearing is 100 degrees, which means from north it's 100 degrees around. That also means that if I were to create an acute angle, I would subtract 90 from that, because this is a 90-degree angle, to leave what's left over here 10 degrees. So the 10 degrees is the one that I'm going to be working with. We also know that the flight is 2,472 miles, and that's going to be the hypotenuse in any right triangle that I draw. So if I'm going to find how far west and how far north to get from Miami to Reno, this is the distance north, and this is the distance I would travel west. So from this 10 degree theta, from 10 degrees, North is the side opposite, and of course the hypotenuse is 2,472. So I would be using the sine function because it's opposite and hypotenuse. To find west, I would use the cosine function because it's adjacent over hypotenuse. So my two equations would be sine 10 is equal to n divided by 2,472, and cosine 10 is equal to west divided by 2,472. Multiplying each side by 2,472, I get the approximations of 429 miles north and 2,434 miles west of of Miami. Now let's take a look at bearings. So this one will actually be a lot easier. I'm going to get rid of all my markings. If I want to think about bearings from Miami to Reno, I want to think about Miami as being at the center of the origin. So now this is still 10 degrees. So what's the bearing? Well, starting here, I have to go all the way around. So that's 90 plus 90 plus 90 plus 10, or 270 plus 10, which is 280 degrees. Let's take a look at a ship navigation question. And the ship navigation is just a little bit different because instead of just north, we're looking both at north and south. So when you get a measurement like north 54 degrees west, they're saying from this north line, go 54 degrees towards the west. Whereas if it said south 54 degrees west, it would say from the south line, go 54 degrees west. So that's the difference between airline navigation and ship navigation. So let's take a look at this question. We have a ship leaving port at noon. So this is from noon right here. Heads due west at 20 knots or 20 nautical miles per hour. At 2 p.m., so for 2 hours, so notice I've labeled this as 40, which is 2 times 20. So at 2 p.m., the ship changes course to north 54 degrees west. That's that angle. Find the ship's bearing at 3 p.m. So this is the ship at 3 p.m. Now, what I know is that in order to find the bearing, I need to know something about this angle. I'm going to call it angle A. If I know angle A, that can help me to determine the angle from here, the angle to get out to the ship at 3 p.m. So let's do the work to get there and then we'll put it all together. In order to find that angle, or any angle, I need at least two sides of a triangle that I know the measure of. But if you'll notice, in the big triangle, in this triangle, I don't know any of the three sides. So if that's all the information I was given, I wouldn't be given enough information. But what I do have is I have this little triangle right here. And this little triangle, I know that this is 20 nautical miles. So because I know one side, I can use that to find the other two sides. Because I know one side and I know an angle. So you might be saying, well, you don't have an angle on that particular triangle, and that's true. What I'm going to do is I'm going to use that this is 90 degrees to take 90 minus 54 to get 36. So this little guy right here, 36 degrees. Now, the other option, should you have chosen to do it that way, is to use this angle at 54 degrees, and that would have worked just fine too. That's not the way I did it, so we're going to stick with the 36. I'm going to start with this angle, 36. The side opposite is A. The hypotenuse is 20. So notice I've written sine 36 is equal to A divided by 20. And then instead of finding a decimal equivalent using my calculator, I've just rewritten it by multiplying by 20 on each side to get A is equal to 20 times sine of 36 degrees. I'm going to do the same thing with B. From my angle, I have the adjacent side is B and the hypotenuse is 20. So just as I did, I have cosine of 36 is equal to B divided by 20. And then I have b is equal to 20 times cosine of 36. So now what I have for my big triangle, let's look at the big triangle. For the big triangle, I still don't have this distance, but I don't need it because in order to find an angle, I need two sides. And I now have side A, which is this distance, and I have this whole side, which is B plus 40. So notice I'm taking B plus 40. So tangent of angle A is equal to A divided by B plus 40, or 20 sine 36 divided by 20 cosine 36 plus 40. And again, notice these are in degrees, so you need to be using your calculator in degrees. The question is, from here, how do I find A? Well, we haven't really practiced this much yet. We did talk about the fact that you could take the inverse tangent of each side. And again, you must be in degrees. If I do that, I'm on the left going to end up with just A, and that's what I'm going to do. I'm taking the inverse tangent of each side to find the value of A is 11.82 degrees. So you might say, great, I'm done, that's all I needed. 11.82, I'm a genius. But remember, it says, find the ship's bearing at 3 p.m. So what is the bearing? The bearing from here is this distance. So I'm going to take 90 minus 11.2 to find 78.18 degrees. And remember, this is north and this is west. So the bearing is north, 78.18 degrees west. For our last example, we're going to look at harmonic motion. A point that moves on a coordinate line is in simple harmonic motion when its distance d from the origin at any time t is either given by d equals a sine omega t or d equals a cosine omega t, where a is the amplitude, just as it was before, 2 pi divided by omega is the period, and omega divided by 2 pi is the frequency. So let's take a look at an example that uses one of these. A buoy oscillates in simple harmonic motion as waves go past. The buoy moves a total of 3.5 feet from its low point to its high point and returns to its high point every 10 seconds. Write an equation that describes the motion of the buoy where the high point corresponds to time equals 0. So we'll start with this. The high point corresponds to time t equals 0. What that tells me is between sine and cosine, where sine goes through at 0, 0 and moves in this fashion, and cosine goes like this, the high point is time t equals 0 tells me I'm using a cosine function. Next, let's take a look at what other values I can find. So I don't know omega, I don't know A, but I can find omega because it says the high point is every 10 seconds. Well, that tells me that the period, 2 pi divided by omega, is 10, and I can solve to find omega is pi divided by 5. And I can also say that since the buoy moves a total of 3.5 feet from its low point to its high point, then that means the amplitude, so if you'll recall, the amplitude is the distance is twice that distance, right? So if this is 3.5, the amplitude is half of that because the amplitude tells me the distance from the center. So I'm going to take 3.5 divided by 2, which is 7/4. You could have also written that as a decimal if you'd wanted. Now, from here, what do I have to do? All I'm trying to do is write the equation. Well, I already know the equation is going to be d is equal to a cosine omega t. Well, I just found a is 7/4 and omega is pi divided by 5. So my final answer is d is equal to 7/4 cosine pi t divided by 5. Up next, we're on to Chapter 5, Section 5.1 is using fundamental identities.